Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on the law of large numbers. I wish to thank Mrs. Borlaug for allowing me to use her PowerPoint presentation in making this series of videos on probability. This is the second video of this series, and we will pick up with example 1. Students may need to watch the first video of this series to understand all the concepts. We are still looking at that same population as from part 1 of this series, and we're looking at a population of 30 students, of whom 9 were wearing sneakers. And an experiment is selecting one at random and then putting that student back. And the directions for this example is to run the experiment 6 times and estimate the probability of getting sneakers. Excuse me. So here we have our population, and we're going to actually run an experiment using our TI-84 calculator ourselves at randomly selecting some of these students. To aid in doing this, Ms. Borlaug created a nice visual for us of our 30 students, with 9 of them wearing sneakers. And remember that the first step in selecting a random sample is to number our sample. So there we've numbered our sample. And if you need to review how to find a random sample, I do have a video on that as well. For this video, I will proceed as if you remember how to find the random number on your calculator. Using our TI-84 calculator, we have generated a random number from 1 to 30, and that is student number 17. And student number 17 does not wear sneakers. We'll generate a second random integer. That is student number 13. And student 13 is not wearing sneakers. Student number 10 is wearing sneakers. Student number 7 is not wearing sneakers. Student number 13 is not wearing sneakers, and student number 16 is wearing sneakers. In this case, it does not matter if we repeat a value as we're putting the student back into our selection. And remember, if you do this at home, you will not get the same numbers that we did here on the screen. You will get a different sample of 6. And we have now run the experiment, we have run the experiment 6 times. So here are our 6 results, and we will show our work. And Ms. Borlaug does this because she wants her students to know how to do this. You may not be required to do this part, but this is how she wants you to show work for Ms. Borlaug, and that is to write the calculator command, which is random integer 1, 30, and then show the selections that were made. Student number 17, 13, 10, 17, 13, and 16, and the results: no sneakers, no sneakers, sneakers, no sneakers, no sneakers, sneakers. And then that shows the work, the calculator command, and the results. And so in this case, we ran the experiment 6 times, and 2 times I got a student with sneakers. So the probability of sneakers using the empirical approach or the relative frequency approach is 2 out of 6, and that is called the relative frequency. And notice in this case, it is greater than the true probability that we got in part 1 of this series. So it will not always underestimate. Here is an exercise for you to try. Select one at random and then put it back and run the experiment 11 times and estimate the probability of getting sneakers. Show the work and include the calculator command used. Pause and try that, and then think about these questions. Will the results always be below the true probability? Will they always be above the true probability? No. As your sample gets larger and larger, your answers will begin to approach the true probability, so that the relative probability or the relative frequency will begin to approach the true probability. Here are some results for when n equals 20, n equals 80, and n equals 320. Notice that as you look at this, as the number of experiments gets larger, the numbers begin to average out closer to the true probability of 0.30. The numbers here at the bottom set, where the number of experiments was 320, were much closer to 0.30 than the numbers here, where they were kind of all over the place. Here's a second exercise that you might like to try. Run the experiment 22 times and estimate the probability of getting a mountain climber. Again, remember, your first step would be to number your population and then use the calculator command. Pause if you'd like to try this one. And there's a third exercise for you to try as well. Run the experiment 8 times, then 26 times, and then use the classical approach to see what it would be. Again, you may pause if you would wish to work this one. Thank you for watching the video. If you would like more help with this topic, be sure that you've watched the first video of this series. And as always, Walters State students are welcome to stop by and see me in MBSS 222.